Hello and welcome to this carbon tutorial. Here we will be looking at how to use the carbon crease node in conjunction with the carbon mesh allowance node to add a fold angle or a crease angle onto an open edge where two meshes are being stitched together. So let's start having a look at the setup. Here we basically have just two cloths, a yellow and a red cloth, that are being stitched together, and the top one is also being bound to a collider, so it just hangs off the collider. Now our stitching is very tight. If I look at the parameters, we can see we have a compression of 0, equilibrium is 0, and give a little bit of extension to avoid over-constrained situations. Now, when you bring two pieces together like this, it's almost like a smooth seam, so that you stitch two pieces together in real life. You don't want any gaps appearing here. What's very important is to make sure to also create a carbon narrow filter. You can create a narrow filter just by selecting the stitching you want to create it for, then click on the narrow filter button. So with the narrow filter, we get very smooth behavior. If we did not have the narrow filter, and I will turn it off now and run the simulation again, here's what we get. This is because the thickness of cloth is also extruded along the open edge. So by us stitching these two cloths together with basically 0 distance, what we end up getting is the thickness on the open edges fighting each other, and we have collision fighting the stitching. So whenever you have tight stitchings, make sure to activate or create a narrow filter. Here we go. And we can play this now. Perfect. All right. Also, if you hide the cloth, you can see the physics of the carbon narrow filters right here. You have these sets of triangles filtered against this set of triangles. All right. I'm going to show the cloths again. I will now hide the narrow filter physics draw. Okay. So how can we get an angle enforced on these open edges? Well, in carbon, you can use the carbon crease node to enforce an angle between two triangles. So an edge that's shared by two triangles, you can set an angle, override an angle, and you can set a strength on it. Now on the open edges, obviously we don't have two triangles hitting the open edge. We only have one, which is the definition of an open edge. So how can we now enforce a crease? Well, our strategy is to use the carbon mesh allowance to actually extrude geometry, so our open edges will not be open edges anymore, which means then if it's not an open edge, we can enforce an angle. All right, let's get started. I'm going to hide the carbon simulation. So by selecting it and pressing H, let's also just hide the stitching and binding. We do not necessarily need them right now. Let's bring our top plane up. And I've hidden the output mesh, and I'm showing the input mesh because this is the one we want to edit. Select the input mesh and I'll click on the carbon mesh allowance button. Also, you can find it here under the carbon menu items, and then under utils and mesh allowance, just under crease. So it's really up to you if you want to use the menu or if you want to use the shelf. I'm going to use the shelf. Again, select the mesh and click the mesh allowance button. Now we have specified the mesh onto our mesh allowance. We need to now click add allowance. Let me hide the extra attributes. And here we need to specify a point group. We want this point group down here, which is also the one being used in the stitching. So we can either manually select it down the viewport, or we can just use our points from the stitching. Copy these, now put them into the mesh allowance. There we go. All right, we want a width, or this basically extrusion height. Let's just set it to a number to see how big it is, 0.5 for example. I now click update output mesh and I get the output mesh. Well, clearly this was a bit too big, wasn't it? All right, so what can we do? Let me hide the input mesh first, and we just see the output mesh. This is too big, and we want to set the extrusion height to roughly the same length of edges in this mesh. Since I've set up this mesh and the tessellation, I know that a good value will actually be 0.02, so 2 centimeters, because we're currently working on meters. Let me update the output mesh. And there we go, that looks quite nice. Let's show the tessellation with this button. There we go. It doesn't have to be perfect, it just has to be roughly the same size. Next up, we have angle. Angle tells you if you want these to be extruded straight ahead or if you want them like forward or backwards. I'm going to choose an angle of 90 degrees. And when I press update output mesh, you will see the difference. There we go, it is now extruded towards the back. The next parameter, curve type, open or closed. We only really have one choice right now because our point group here does not form a loop. If we had a loop, a closed loop, then we could choose closed. If I just press close now and go to update output mesh, we will not see anything because it is detected that we are not dealing with a closed loop, so nothing will happen. Let's go back to open update output mesh. There we are. All right, the last parameter, extrusion type. You have the option between darted and band. What we see right now is darted. So these are little darts, or you can call them saw teeth or whatever you want to call them, little peaks. If you go to band and now press update output mesh, we see that the gaps between the teeth has been filled with extra triangles. Now this will make this allowance, this like extrusion, much more stable because each tooth is now actually connected to a neighboring tooth and it cannot just independently go forward and backward. So it strengthens the whole system. The downside of this can be when you have a geometry that then will undergo strong deformation. Imagine this grid forming a tube. So if you try to roll this up into a tube, what we will get with the banded extrusion type is that these triangles in here will actually fight the compression when you try to roll this. Not only will the surface preservation, but also the edge preservation of these open edges here fight the deformation when you try to roll it into a tube. So keep in mind, whenever you have strong deformations, you want to stick with darted. But here, we're not trying to actually roll up the grid, we just keep it straight. We're using band extrusion type, which makes the whole thing more stable. All right, that's the first one done. Let's quickly hide this one and let's move to the bottom mesh. All right, oops, bottom, there we go. Similar spiel, we select the input mesh, we click on the mesh allowance node, and we have created a new mesh allowance here. Add allowance, and we will go back to our stitching and select the points from the stitching on which we want to create the allowance. We know we want 90 degrees, and we know we want 0.02. And we go with band again. Okay, let's update output mesh. Oops, there we go. I forgot to click it. All right, I'm going to hide the input mesh. And here we are. We now have our output mesh here. Now, what has happened? We actually did not transfer our translation of this mesh. So our bottom mesh is minus 0.2. So let's bring this one in here, minus 0.2. There we go. And now they're overlapping again. All right, so we have our bottom allowance and we have our top allowance. It is now very important to make sure that these are actually overlapping. We do not want one allowance pointing backwards and one forwards, because when we update our stitching to take into account the allowance meshes and the allowances, you will have point-to-point stitching between these new extruded allowances. So if one is here and the other one is there on the first frame, we're going to get basically a jump trying to bring the points together. So it's very important to make sure that they overlap nicely and they have a seamless connection. All right, now let's move on and pass this to the simulation. We go on our top cloth. And we're now going to change our start mesh to the top allowance mesh shape. All right, same thing, the bottom one. We're going to change this to go for the bottom mesh allowance shape. All right, and show back the simulation. I'll hide the meshes and I need to change this. There we go. All right, let's run the simulation and see what happens. All right, we have our allowance now simulating here, but what has happened with the stitching? Well, if you look here, actually nothing has happened. We still have the original stitching. We want the extra points to be stitched as well. So these stay together and we can actually then later enforce an angle. Where do we get the extra points? Well, we can go to allowance meshes and select them manually. Or the other option is, if you go to your allowance node, go to extra attributes. That is the allowance for the top mesh. If you scroll down to extra attributes, it actually shows you your input group. It also shows you your allowance points or the whole points. So the input plus the output group together. So I can now select these, copy, go back to my stitching shape and paste them on the top. I can do the same thing for the bottom allowance. Let's go here and we have all the points being shown here. Go to our stitching, reset the simulation, and now you see we have our stitching points. Very cool thing about the narrow filter is that since we're not specifically specifying a point group, but actually a stitching shape, our narrow filter will automatically have been updated based on the stitching. And here you can tell it takes into account this new allowance. All right, I'm going to hide the narrow filter again. I'm going to hide the stitching because we're happy with the setup. All right, let's bring back our cloths. Now, we can obviously simulate this, and it's hanging down and we haven't added an angle yet. But before we tackle the angle, let's have a look at this. While we filter between the top and the bottom mesh in this allowance area, these will still collide with all other objects. So imagine this was part of a t-shirt on an avatar. You would not want this extra now extrusion, this extra part of the mesh, the allowance, to collide with the avatar or maybe with other layers of cloth. So what we need to do is we actually need to remove the primitives, the part of the top and the bottom cloths in this extruded area from the collision geometry of the cloth. How do we do this? Well, if you look at the cloth, it says here in the collision face group apply selection also all primitive of the cloth are being used for the collision. Now what we want to do is we actually want to subtract the triangles that are in the allowance here. All right, I'm going to hide the simulation and I will now show the allowance meshes. Let's start with the bottom one, for example. Select here the mesh, right click, go to face. All right, let's select the faces here on the extrusion. I'm going to hold Control, go on the bottom mesh, and now here where it says apply selection, I will do remove. I will do the same thing on the top cloth. So hide the bottom cloth, show the top cloth, go to my mesh, right click, face. Let's select the faces. There we go. Hold Control, click on the top cloth. I can now let go of Control. Where it says collision, apply selection, I go to remove. All right, let's show back the simulation. Hide the meshes. Reset our simulation, and we can see they have now gone. They're not part of the collision anymore. Obviously, keep in mind that while they're not part of the collision, they are still part of the cloth. So they still have our stretch constraints, bend constraint, and surface constraint, which is what we want. We want it to be part of the cloth. We just don't want it to collide. And we can verify this by going down and changing, for example, our physics draw mode to soft primitives. And here we see now the soft primitives of the top cloth. You will not see them in collision mesh or collision surface because they're obviously not part of the collision. All right, now we have the setup and we can just run the simulation again, reset and run. And we're basically where we started, but now we have the extra mesh allowance, which means our formerly open edges are now not open edges anymore, which means we can now add a carbon crease. All right, let's hide the simulation again and let's go to our cloth here. I'm going to select the input, the start mesh cloth, and let's click on crease. All right, it has passed our mesh here. We're going to add a crease now. Where do we want to add the crease? Well, we want to add it on the original point group, but we actually need to be the edge group here. All right, we can just right click here, select our mesh. There we go, right click, edges. And I'm gonna select these edges now, from left to right. Hold Control, go to our crease, and press Replace Selection. Now we have our creases, and we have the name being displayed. I do not really need to see the guide geometry, so I'm just gonna hide the crease node actually. All right, now let's go. Default, I usually set strength to 100 to see what happens. It's usually pretty strong, but that's what I want. All right, angle. I'm going to keep this for 0 now, but I do not want to replace the angle because we took great care to have a 90-degree angle here in our reference. Remember, for our cloth, the reference metrics and angles are being taken from the reference mesh. We do not have a reference mesh provided, but we have a start mesh, which means all the reference metrics and angles will be taken from the start mesh. Our start mesh here has a 90-degree angle. So that we set in the crease works based on this 90-degree angle in our crease here. I do not want to replace it, which would flatten it. What I want to do is actually add. I want to add or subtract, depending if I do positive or negative number in the angle here, a certain angle so that we can enforce an angle between the two meshes. I'm just going to set it to add and 0 right now, just to basically get the basic setup and nothing happening. All right, let's get the second crease going. Where's our second crease? The second crease has to be created from the other mesh. So we go to the bottom mesh. Let's hide the output. We need the input mesh. Select crease. And here we are. Let's add one crease. Go back. to our mesh. Maybe we hide the top mesh. Here we go. Right click, edge. All right, again we select left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold Control and go to the crease node, apply selection, and here now we have our crease. Perfect. Again, I do not necessarily want to see it, so I'm just going to hide it. I'm going to change replace to add and 0 and strength to 100. So next up, we need to actually pass the creases to our cloths. Let's go to the top cloth, and under reference, you see a section called creases. So we want to pass the top crease. Similar bottom cloth, we want to pass the bottom crease. Let's reset the simulation. I'm going to show it now. Hide the mesh. All right, reset, and let's run it. And we shouldn't really see any difference because all we're doing is actually enforcing the existing angle because we're adding 0, but we're making the crease stronger. All right, so now how can we get a 90-degree angle between these two? Well, 90-degree means we just have to add 90-degree to the crease. So we can do this going to the first crease, for example, adding 90. Let's reset the simulation and run this. There we go, we have a 90-degree angle. The other option would be put it on the second one. So let's revert this to 0, go to the second one, set it to 90. Reset the simulation, and we get the same result. Or what I generally like to do is actually split the difference. So I'm going to set 45 degrees in each of them. So we get half the angle being applied to each. As long as they add up to 90, we get the same result. And also keep in mind that our angles are signed. So if I set it to minus 45, on each of them, we will get the crease pointing in the other direction. Here we are, and it points in the other direction. We get a 90-degree angle. Well, I hope this all made sense and hope you have fun using this node as much as I do. Thank you for watching.